Yo, let's finish this up. So 8a, we're graphing rational functions, which means I need to tell you what a rational function is. So a rational function is the something of the form like y equals something over x. X is on the bottom of a fraction. And all these graphs are pretty cool because they look like butterflies. And I'm going to show you 3 graphs today, and then we'll be done. If you miss the fact that graph paper is a thing that exists, I have some that you can like print off if you have a printer. But otherwise, we're going to graph these together by hand, so it'll be all good. Sorry about the random whirring outside. I'm an adult, so people give me like household things for Christmas. I got a Roomba for Christmas. And it's really noisy and I hate it. But I named a dog, so that's okay, right? Okay, so here's what we're gonna do. We're gonna take 2 colors. One is for the horizontal asymptote, and the other one is for the vertical asymptote. Now we talked about asymptotes back in unit, I don't know, when we talked about exponential functions, but here we're gonna have 2 of them. You want to guess what the numbers are? Yeah, it's the -2 and the -4. So the -2 is our horizontal asymptote. I had to think about which way was which. So we're going to have an asymptote here at -2, which means that that's the line that the graph cannot cross. That's called the horizontal asymptote. Or we're going to shorten that to ha in a second, and that is the line y equals -2. X can't cross there. I even closed my door for this. Okay, and then x minus 4. This -4 part is the vertical asymptote. Okay, it's going to be down here. Okay, so like usual, it's backwards. Always. Half of algebra 2, I told you in the beginning, was figuring out which way it was backwards and which way it was forward. X equals +4 is my vertical asymptote, so it'll be over here. Okay, my graph can't cross this, but it'll cross everything else. And it looks like this. Let's not worry too much about exactly where the points go. I'm going to show you in a second where the points like officially go, but let's talk about this. So normally, so this is my new 0, 0. I'm going to have a point like over 1 and up 1 from that 0, 0, and then also over here. Okay, and then it's going to be beautiful. Ready? It's going to kiss the graph, come through that point, and then kiss the graph on the other side. Same thing over here. Kiss the graph, go through the point, kiss the graph on the other side. I'm done. It's not always going to be 1, 1 from here. That's just because it's a 1 on top. If it's like a 4 on top, it'll go through 1, 4, and 4, 1. But we're going to do that one in just a second. But that's a rational function graph. It makes this really cool butterfly. The only thing we need to talk about now is the domain and range really quick. So my domain, what are the x values that work for this graph? Well, I can have all these x values until I get to this dotted line, and I can have all the other ones. So what we write is we write x as all real numbers, but we write x can't be 4, because that's the number from there. Should I color code this? Of course. X can't be 4. Take a look at the picture. This is actually a lot darker than it looks in here. And then the range, what y values work? Well, I have y values all the way here until I get to this dotted line, and then I have all y values all the way up. So y is all real numbers, but y can't be -2. Okay, so I'm going to have you graph and find the domain and range, and also identify the asymptotes. So those all 5 parts are part of this. Let's do another one. Let's graph. Let me write it out and I'll show you. Hold on. I don't know if that was a cool transition or not, and I'm never gonna know, so I don't care enough to watch it. Okay, so we're gonna do the same thing again though. Our horizontal asymptote is gonna be up at 1. Our vertical asymptote has not moved, so it's gonna be at 0. If it helps you, you can draw a line straight down through 0. Somebody's gonna ask me, Miss, why isn't it 4? Well, 4 is my stretch factor. It's not gonna move it left or right. And then here's where the 4 comes in handy. So remember how I said it was 1 and 1? So here it'll be 1, 4. 4, 1. That doesn't really make any sense when I say it out loud. I'm like going from 0. This is my new 0, 0. It's moved up 1. So then I go 1, and then I go 1, 2, 3, 4. And then I go 1, and I go 1, 2, 3, 4. That's how that works. If you're ever not sure, you can always plug in numbers, or you can ask your calculator to plug in numbers. I don't care. It'll also go through 2, 2, but that doesn't really matter. So it's going to go through this point, through that point, go flat. This point to that point goes flat. And it curves. Notice that it curves through these. It doesn't go like boop, boop, doop. No, it doesn't go like that. Let's do those 4 things. So we're going to do the horizontal asymptote, the vertical asymptote, the domain, and the range. And we can do all of these. I'm going to use these colors to like color coordinate a little bit better. So the horizontal asymptote was moved to be +2, or sorry, +1. So that's y equals 1. That should be orange. Normally I pause this so you don't see me stress out. Okay, 1. The vertical asymptote is x equals 0. And it's because there's no number right here. The domain is all real numbers. X cannot be 0. That should have been blue. I'm stressing myself out. If there was a number by the x, this would be a different number here. And then the range is all real numbers. Y is not equal to 1. Okay, did it. Let's do one more. If you want to, you can pause it after I finish writing it, and you can try it on your own and then come back and check. Only one little thing's changing. It's not going to be that big of a deal. All right, so you can pause this here and see if you can do it without me. Oh, you're still sticking around, or you're just checking your work? Okay, let's do it. So this +2 means that the horizontal asymptote is up at 2. This +1 means that my vertical asymptote is going to be at -1. Here's what the -3 does. Instead of it being a butterfly like this, it'll be a butterfly like this. So what that means is normally I would go like over 1 and up 3, but I'm going over 1 and down 3. Down 1 over 3. Back 1 up 3. Up 1, back 3. I feel like that only makes sense to me. To be honest with y'all, this part really doesn't matter to me as long as you have the right area that the graph is. But I think other teachers care, so I'm going to try to teach it better. I care that the swooshes are in the right spot. So see how it's different, right? It's not like this, it's like this. I'm waving my arms, I promise. I'm a beautiful butterfly. Okay, let's try to do those 4 things again. Horizontal asymptote, vertical asymptote, domain, and range. Y equals x equals. Okay, I just wanted that there so I could like do this easier. Okay, so this +2 was my horizontal asymptote. It's where y cannot be. And that +1 means that my vertical asymptote is at x equals -1 and x can't equal -1. That's all she wrote. You got it? Okay, email me if you're confused. I'm here for you. Goodbye.